Alright, in this lesson we're going to talk about inverse functions, okay? Remember, a function is a set of ordered pairs that have no like x values. Remember our basic definition was no x could repeat with a different value, or it passed the vertical line test. The inverse of a function represented by this f with a -1, we say it f inverse of x, simply means we're going to switch the x and y values of our function, our original, and that is going to be our inverse. Think of it like this. When you're trying to find out, you want to make an undoing operation. If you buy 10 MP3s and it costs you $15, wouldn't you like to know how many MP3s $15 would get you? Well, if you can construct that inverse function, then if I had $20, how many could I get? So building an inverse is going to be important. All right. So if I have it as a set of ordered pairs, the inverse is easy. Just swap your x and y's. So the inverse function of this is just 2, 1 becomes 1, 2, 3, 2 becomes 2, 3, and 4, 3 becomes 3, 4. Okay. That's our inverse. Okay? The x and y's switch. Now notice, this is important for us. The inverse of a function is not necessarily a function. Okay? This one was a function. Notice how the x's didn't repeat. But if I looked at x squared from -2 to 2 using just the integers, you can find the inverse by just swapping the points. So it's 4, -2, 1, -1, 0, 0. Swapping 1 and 1, you get 1, 1. And 2 and 4 should swap. This should be a 4. 2 squared is 4 left. Notice how 4 goes to -2, but it also goes to 2. And if it's a function, we're not going to have that. So this is not a function. It's still an inverse relation, but it's not a function. We're going to deal with inverse functions. Now what's nice is, in order for it to have an inverse function, we have to use the definition of one-to-one. A one-to-one function is a function in which each member of the domain corresponds to one and only one member of the range. Okay. It also works backwards, vice versa. That is, every member of the range has one and only one member of the domain. Okay? So, think about it. To be a function, every domain has to have one range. Right? That was the vertical line test. If it's going to be for every range, you're going to have only one domain. That's actually the horizontal line test. Okay? To be a one-to-one function, you must pass both the vertical and horizontal line test. So remember that. One-to-one passes the vertical line and horizontal line test. Okay. What's nice is if you pass that, the inverse is also a function. So when we're dealing with inverse functions, I always need to check to see if the original is 1, 2, 1. All right. Now I don't have a list of steps to do it, so we're going to create a step list to do it. All right. So I get my thing there. All right. New page. Here we go. Here's the steps for finding an inverse. All right. Step 1. Is it 1, 2, 1? If it is, your inverse relation will become an inverse function. If it's not 1-to-1, it's not going to be a function. So if they ask for a function, if it's not 1-to-1, the original, it doesn't have an inverse function. So you're done there. But if it is 1-to-1, we go to step 2, which is if there's an f of x or f or g of x, make it y. Okay. After that, you're going to swap x and y. Wherever there's an x, you put a y, and wherever there's a y, you put an x. Step 4, you're going to solve. Okay. For y, just like we always want. We like y equals. We're going to solve for y. And step 5, if it was in function notation, change y to just f of x, but make sure it's its inverse, f inverse of x, or g inverse of x, whichever the letter they chose. Okay. So let's go do some. So let's write the inverse. Step one: is this is this 1-to-1? This is 1-to-1. This is a line that looks something like that. It's got a slope of 4 and it goes up like that. It's pretty steep actually. All right. Step one: it's 1-to-1. It passes the vertical and horizontal line test. Step two: change fx to y. Step three: swap. Step four: solve for y. So I divide by 4. Y equals x over 4, which I'm going to rewrite it in function notation. F inverse of x equals x over 4. That's it. There's our inverse function. Step 2. We take a look at this one. I'm going to call this is a line. Its slope is 1, y-intercept -2. So it is 1-to-1. So it's y equals x minus 2. Swap, x equals y minus 2. Add 2, y equals x plus 2. All right, and because it was in G notation, I'm going to call it G inverse of x is x plus 2. And that's it. Now let's just see what happens if you plug in a point, so you know. See what you're getting. Plug in 8 to the original. Plug in 8, 8 minus 2, you get 6 out. Watch what happens when you plug in 6 to this one. 6 and 8. Notice how the points just swapped. Okay, so you can see that the domains and ranges actually are going to switch in these, which is kind of cool. All right, this one right here just changes to y. By the way, this is a line. That is a relation. That is a function, and it's 1-to-1. Swap 1/2 y minus 4, and then solve for it. X plus 4 equals 1/2 y. To get rid of the 1/2, you multiply everything by 2. I cancel that out, and you get 2x plus 8 equals y. And then we're going to replace y with f inverse of x, which is 2x plus 8. Okay. Over here, if you wanted to, you could move the 3 over, and you're going to see it's 6x plus 3 has a slope of 6, y-intercept of 3, another line. Lines are 1-to-1. So to swap here, x minus 3 equals 6y. Notice I didn't have to put the f of x notation, didn't have it. Solve for y by dividing by 6. X minus 3 over 6 is y is our inverse. Now sometimes I might write this as f inverse of x. That's okay, that's the same idea. Okay. If I take a look at y equals x squared, it's not a line, but a parabola. If I look at it, it's parabola shifted 1 unit down. Is this 1-to-1? No, it's not. This is not 1-to-1. So there is no relation, or there is no inverse function. Okay. No inverse function. Now, is there an inverse relation? Yeah, and it's solved the same way. All you have to do is swap x and y. X equals y squared minus 1, and you can solve that. X plus 1 equals y squared, and take the square root. Catch is, you took a square root, you go plus minus when you take it. Right? And that's why you can see we have this plus minus. That's going to create it not to have an inverse function. The inverse won't be a function. It's an inverse relation, which does work, but there's a difference. All right. The last one is a line that's going downhill. Doesn't make a difference. It's 1-to-1. So x equals -5y. Divide by -5. Y equals x over -5, or -x over 5, whichever way you want to write it. And that's our inverse. Okay. We have a couple more if we wanted to. If we wanted to find the inverse of this, all I got to do is call this y equals 2x minus 3. And then just swap. X equals 2y minus 3. X plus 3 equals 2y, and then divide by 2. So x plus 3 over 2 equals f inverse of x. Oops. All right. Over here it says, ooh, not only does it want the inverse, but it wants the inverse evaluated at 2. Well, we can do this by just simply making this y equals 3x, or 3 over 4, x minus 5, swapping, 3 4 y minus 5, add 5, x plus 5 equals 3/4 y, and then we multiply everything by 4/3. The 4/3, we'll get rid of that 3/4. Okay, now if I write this as 4/3 x plus 5 equals y, we do have it, or g inverse of x. Well, can I now evaluate it at 2? Well, yeah, just plug in 2 for this. So g inverse of 2 is 4/3 2 plus 5. It's 7 times 4, which is 28/3 equals g inverse of 2. Now, remember, there's a relationship between the original and what you're plugging in. Remember, this is, if I plug in 2, I got 28 out over 3. Well, if I wanted to find out what it was from the original, we are going to get, this is the x coordinate, so it should be the y coordinate of the other one. Now, obviously, it's going to shoot out 38/2. Okay, the unknown here. It's going to shoot out 38/2. But how could I have done it without even using the inverse? Just plug in 2 for y, because that's what it is. 2 equals 3/4 x minus 5, and you will get the same answer. All right? So, what we're going to do is we're going to stop there. There's going to be a continuation of this video. We're going to take a look at the graphing parts and the composition afterwards. So keep looking for part 2 of this one.